Hello and welcome back to another Advent of Code video. So picking up from where I was the last video, working on day 9. So this one we are kind of simulating a rope, but it's a really tiny rope that the other end of the rope stays right next to it when you kind of pull it along in a grid. And we are basically following a bunch of steps, so that's our input. We go right and we go up, and that's moving the one end of the rope, and we have to kind of simulate where the tail end of the rope goes, and the answer is going to be the number of places the tail has gone. Now this day I've also tried to use like a few new features, well, not really new, but yeah, kind of a few features of jakt that I haven't been using so far. And I kind of ran into an issue. I have been trying to do like a dictionary of the point, which is a structure I define, to a boolean. But the issue is that this needs like hash function or something like that, and I think it's kind of not implemented in the jakt side. I've had a bit of a look at the compiler and I'm a bit of a loss. So I've tried stuff like this, having a trait and then hash pool and then do that, but that's not quite working. So what I think I will do is, and I also, because I observed that point is just 2 digits, I also thought I could try, instead of a point, we could have a, not that one, not that one, that one. So you could have a tuple as the thing, but that kind of ran into the same issue, that tuple doesn't have a hash defined. So what I think I'm going to do is just go with a U64 to bool, and U64 to bool, and I'll have some functions from U64, a non-U64, I'll call it I, maybe I'll call it U, and this is going to return us a point, and for now we can just have that, and we'll also have a function to U64, and this will take this and it will return a U64, and this we will also to do and just return 0 for now. And this way we can have our head and tail like this, and when we have this visited, now I also kind of want to maybe just have a set of U64s. So I was thinking part 2 like might be yeah, I mean it works with dictionary, like the code should still kind of work. I'm thinking part 2 might be something like count how many, like was the coordinate that got, well, at the coordinate that had the most number of visits from the tail of the rope, how many did it, how many were there, in which case a dictionary would be good. And here we can go tail to U64, and I think that is kind of all we need to do, apart from kind of all these to-dos that we've got. So we've got a move rope that we need to do, and I think this kind of simulates it fine enough. We like parse the direction, and I think we've already done that. Yeah, so we parse the direction kind of nicely. Oh yeah, and yeah, this thing. Oh no, I was thinking, yeah, this is what I can do. I was also having a look at some other Advent of Code solutions done in Jakt. I might even put some links in the description. But yeah, I saw that there were some things that you could do, like instead of doing this as cchar, we can just have a b prefix of a character, which will convert it to the byte, which is U8. So I think that should do that trick. So I think at this point we should be able to compile. No, I don't want that. I was I was making a test file basically just to see how we can do things, but we don't actually need that. And I want test.sh. Right, so we aren't doing hash build anymore. That's all right. The scroll. Right, so we've actually taken that away from the other places that it doesn't need to be, so we can do that. Alright, so this is looking good, looks like it compiled, so we're in a better state. And we're kind of at the point that we just need to implement all the right things. I might just double check that what the kind of input looks like, because I think this is the first time we've actually parsed the input and done it. So right 4, up 4, left 3, down 1, right 4, down 1, left 5, and right 2. Now, so what could be cool is to actually like simulate it as they've kind of done here, but what I think I'll do is not do that and just kind of simulate it as in like we're not actually storing anything in a grid, we're just showing what the points are. So how we are going to do this. So I think we need to have a which I wonder if we're allowed to have a width which will be a U64. And another thing I saw was we can do something like that, which might be better in some ways than so you can do width U64 equals 0, because by default 0 will be I64, I think, or you can kind of suffix it there, which if you say by accident go like this and you're like, oh, I wanted that actually to be a U64, you can just write U64 there. In my case, I actually don't care if it's a well, actually I kind of want it to be a U size, which I think that is the suffix for. And so when we get a line, we actually want to set width to be line.length, which will return a U size, so that's good. Because in the 2U64 code, we don't actually need the from U64, but in this we will basically have something like x times no, we want y times width plus x. So we can actually probably just return that y times width plus x, and that may have some typing things. And this to do here, I think I will actually go println to do point from U64 and then just go abort. That's not what I wanted. Right, so we're maybe not allowed to have width like this. So I think we need to also pass in a width, which can be I guess it could be well, I'll do U size, and we need to kind of keep track of this with mute would equal 0 uz, and I don't know, I think the string implementation is like reasonably cheap on the length, but we probably only want to set it if width is 0. Something like that. So that's not right. Yeah. No, because yeah, we don't know what the width of this is going to be. So I think instead of width, we can have just a really high number, and maybe like fix me for like fix me magic value, and this width can be that big, maybe 1 million, and we use 64, so we've got a bit of space to go. So that's like timesing it. Maybe just 100,000. And I believe Yak will tell me if it overflows, which, yeah, I'll do a quick sidetrack. And I equals like 0. And we can probably I times I don't know if they'll do it, so maybe I'll do that, and then do that. And if I compile that, it should compile. And I think if we run that, it should, wait, one more. Maybe it's already done. Yeah, so if I run that, it didn't complain. What should I do? Print line j equals do and j, and maybe add like a bunch more. And compile that again. Like in U64. In fact, like, let's just do 32. And I guess what I'm trying to see is that it should just tell me when it's overflowing. Like, it'll have a runtime error, I guess. Yeah, here we go. Overflow and unchecked multiplication. So that overflows the number at runtime, which is what we kind of want. So we'll get rid of that test file and get back to this. So my thinking here is that it'll just magically tell us. So if we run the tests again, see if this fails. Right, we need to do something like this dot and this dot. Unreachable code there, that's cool. We can just do that. Looks good. Yeah, that looks good. That looks good. Right, so that's fine. It's compiles, which pardon me. That came on real sudden. Sorry. Right. Yeah. So that kind of works, and it might work. It might overflow. We'll find out when we do this move rope. So the move rope, we need to work out how we're doing this. Right. So there are some rules where it mentions. Yeah, so if the head is ever 2 steps directly up, down, left or right, the tail tail must also move 1 step in that direction. Right, so we are moving in direction, so we probably want these to be mutable, I guess, and new head dot x. I wonder if it kind of copies. I'm unsure, so I'll do something like this. Just so we know. Right, so now we need to work out the direction. So our x is going to go to, we'll do a fancy match on dir, and if we have direction left, that's going to go to -1, so we're going to go back that way, and right will go just +1, and otherwise we'll just go to 0. Yeah, I kind of like that syntax. And our y is also going to be the same. So I also wonder if we can kind of just do something like this. And maybe like and then we don't need to have it mutable. And copy that nonsense. And these left and right can be up and down. Yep, and up goes that way. We can, I mean, it's pretty arbitrary as long as it goes one way. Right, so then we don't need that, and we don't need that. And this can probably just be a let now. And the new tail, we now need to see where the tail is. So if tail, gosh, off by 1, then off by 1 on the backspace. I use a different keyboard layout, and I also have like a fancy split keyboard. And sometimes I go off by 1. Right, so if we're two steps directly close, and what's the time? This time is not my local time. I could fix it, but yeah. And yeah, I guess we need to see whether it's actually already touching. So I think I will do a function distance and take this and another point and return a U64. And here, so if it's diagonal, it will be like yeah, it won't be Manhattan. It'll just be actually like the distance. So I guess that kind of counts as one. Yeah. I think I actually just want a is touching. Maybe that will be a bit simpler and like more needed, I guess. So if x equals p dot x and y equals p dot y, that will be return true. And what is another case? If do we have ABS? And that means of this as well. I have a feeling we didn't actually have an ABS, but we did have it in our helpers. Get grep ABS. We didn't make an ABS, right? I'll do that in the helpers. Function ABS, and this can take in a non U, and it'll be U64, and it'll return yeah, I guess it'll take an I64. So if I is less than 0, we can return negative I. Otherwise, in fact, just return I. And if we go back to day9.jakt, also just include ABS. And this means we need this dot x as bang I64. Which I guess if it's like real big, yeah, these points just need to be I64, and these need to be not U, because we can have negative values. And then we won't need that nonsense. And we'll just leave that as is just for now. And where was this? And up to I64, and this will be a I64 this will also be an I64. Right, so if the absolute distance between this dot x minus p dot x, so basically if the distance between the x's is 1 and this dot y minus p dot y, if the distance between both the x's and the y's is at most 1, then it should be in one of the adjacent squares. In fact, at this point we can probably just do this. And that should also cover that, because there'll be 0 and 0. So I'll do that. So now we can go, if head dot is touching tail, and it'll be new head. New head is touching tail. Then we don't have to do anything with the tail. So we can return turn new head and just the same old tail. Otherwise we need to kind of pull the tail along. That's what I wanted. So I'll just double check we compile. I also will need to take off at some point. Oh, yep, we just need to do an anon, I think, at this part. And yep, that one is still fine because we don't do it. Maybe we can try and do something quickly here. Right, so if the head is ever 2 steps directly up, down, left or right, the tail also moves in the same direction. Right, so if tail dot x equals new head dot x and abs of tail dot y minus new head dot y equals 2 on the dot. If that happens, then we just move. Yeah, this will just be the same, except with tail. Tab is there. Something like that, and we can probably just return a tuple of new head and a new point where we're taking tail.x and tail.y. So that is that, and close off that tuple. So that closes that, that closes that, that closes that. Yeah. Right. So otherwise, so we're not touching, and if we aren't in the same row or column, then we need to kind of do both. We need to do a diagonal. Diagonal. Alright, so how do we do diagonal? Now, I have to go now, so yeah, I'll come back to the diagonal part in the next video, and we'll see how that goes. And until then.